For the final lesson in this section, after which you'll be able to name any chemical compound or write a formula for, is, well, I guess not organics, oh well, any that we'll cover in this chapter, is acids. As we've mentioned before, acids are compounds that begin with hydrogen. I've been saying begin with H. You got to be a little careful. Obviously, something that starts with mercury would also start with H because it's Hg, but we're just talking about hydrogen compounds, not just the letter H, but hydrogen. First, let's talk about how you name them. First, you have to understand the structure of an acid. Every acid begins with hydrogen, as we just mentioned, but it's always going to end with some negative ion. These are, of course, known as anions. Negative. And these will, of course, be on your ion sheet. I promise I won't give you any that aren't. And those ions always, as we learned before, have one of three possible endings. All negative ions end in either ide, IDE, ate, ATE, or ite, ITE. Every negative ion ends in one of those. And so your first task is to determine which of those three you have. The other thing to remember, we're going to have to know when we go through naming, is that negative ions also, the negative ion also has what we call a stem, or a root it begins with. This is the part that comes before the ending, before the ending. So if you have phosphide or hypochlorite, whatever comes before those last three letters, we call that the stem. There are two little exceptions that you need to be aware of, only two that I can think of. One is phosphorus. Phosphorus ions stem, for instance, phosphate. From my rules I just told you, phosphate you would expect the root, the stem of phosphate to be phosp. You just take off the ATE. But it's not, it's phosphor. And same with sulfate. You would take off the ending, you would expect it to be sulf, but it's not, it's sulfur. But everything else, it does work that way. Chlorite, for example, take off the ITE, and that's your stem, chlor. Periodate, you take off the ATE, and your stem is period. And so, those are, that's what we mean by stems. Those will be important as we go into how to name them. So, how do we do this? Well, the ending of the ion, ite, ide, or ate, determines how, the rules for naming it. First, let's deal with ide ions, ions that end in IDE. For these, we always do it exactly the same way. We begin with the prefix hydro, and then we stick the stem of the ion in there, and then we finish with ic acid. An example there would be HCl. HCl, we see it's an acid because it has that H, and it has this negative ion chloride. Chloride, there's no O's there, so it ends in IDE, chloride. And so we name this hydro. And then the stem, we have chloride, and so the stem is just chlor. So we chop off the IDE and we put in chlor. And then we end with ic acid, hydrochloric acid. That is why hydrochloric acid has that name. If we do another one, let's do HI. Again, starts with H, so the hydrogen makes it an acid. Just ion is iodide, so we have the IDE ending. And so we want to look for the stem of iodide in a second, but first we got to start out with hydro because it's an ide ion, and then we put iodide. Now we cross off those last three letters, the ide, hydro, iode, and then ic acid, and we're done. And that's how you do ide ions. To do eight ions, ions that end in ATE, it's exactly the same thing without the hydro. So if we have, let's see, we have HClO3, that is an acid. It starts with H, and then the ion there, ClO3, you'll know it or you'll look it up and you'll say, well, that is chlorate. So if we look up here at the rules, we don't have the hydro prefix because it's an 8 ion, and so we just start with the stem. We skip the hydro and we go right to the stem. The stem for chlorate is, top off the ATE, and it's chlor. And then we just say ic acid. So you can see there, chloric acid, we know the formula for it is HClO3 because it's got to be made out of chlorate. Whereas hydrochloric acid, we know that it has to just be made of chloride, so it's just HCl. One other example, let's go with H2C4 H4O6. Now what in the world is that? Well, I told you before it would always just be hydrogen and then a negative ion. Now in this case we have two hydrogens, but that makes absolutely no difference whatsoever. That first hydrogen that we look at here, that's our acid hydrogen. That tells us it's an acid. There's another hydrogen later, but why is it in there twice? Well, because that hydrogen must be part of a negative ion. This must be on your ion sheet somewhere because it's not part of that original H, and it is. That is tartrate. So with the 8 rules, we're going to start with tartrate. We're going to chop off the ATE, leave us with the stem of tartar, and then ic acid, and that's it. We're done. Tartric acid. Maybe the hardest part there is identifying the negative ion. Again, the fact that there are two H's here, we'll get back to, we'll see why that is in a little bit, but we don't need to know that right now. The last kind of ending is the Ite ending, and they work exactly like the ATE ending, except the difference is instead of ic acid, we say us acid. So, as an example, we could go sticking with our chlorine theme here, HClO2 would be, we see that starts with H, it's an acid. The ClO2 is chlorite. We know that it's on our ion sheet, so we chop off the ending, and we say, well, it's chlorite, so that turns into us acid. And finally, one last example. Let's do H3PO3. So we know that's an acid. We look at the PO3 and we recognize that as being phosphite. So we chop off the ending, and you would say phosphorous acid, except that would be wrong. Remember, this is one of our exceptions, sulfur and phosphorus you got to look out for. So the stem of phosphorus is not phosp, it's phosphor. So now we're going to put the OUS ending on phosphorous acid. That is our name. There's a little trick to remembering these. If you can remember how to do ides, there's a trick for the 8s and the ites. I like to say that it's 8 becomes ic, and ite becomes us. And what that helps us is it sounds a little bit like a disease, ATEICITEOUS. ATEICITES. That's a disease that causes people to not be able to name acids. There you go. ATEICITES. Remember ATEICITES. That doesn't help with the ides. You just have to know that one. It's a little confusing because the ic happens for both the ides and the 8s. But the difference, the key difference is the ides have that hydro prefix always. Now, if you can do that, the rest is easy. Doing a formula, you just work backwards. If you have a name and you need to do a formula, you go backwards. So if you're given a name, you got to identify the negative ion from the ending. That's really important. You got to recognize it from the ending. So if you have something that begins with hydro, that should be a red flag that your ion ends in ide. And if it ends in ic but does not have the hydro prefix, then that means it ends in ate. And if the OUS is pretty obvious one to recognize, it means that you are going to end in ite. So what you got to do, if you have to write a formula for an acid, first thing you got to do is to determine what negative ion or anion the acid is made from. Write its formula, and then in front of the negative ion formula, add a number of hydrogens equal to its charge, equal to the negative ion's charge. This is because, for the same reason that type 1s and 2s, you got to balance those charges. It sort of behaves like an ionic in that way. So let's do one of these different. Let's do one of these. Let's say we got hydrofluoric acid. So I immediately recognize that hydro prefix. The hydro prefix tells me that I have an ide ion. So I look for the stem. Fluor looks to be the stem, so fluoride is what I'm looking for. So I go and I look for that, and I see, well, that's F, and it has a -1 charge. So now I need to find how many hydrogens go in front of it, and the answer is the same as the charge. So the charge is -1, so it's just one hydrogen, HF. That is hydrofluoric acid. If you were to have, say, iodic acid, so again, this time there is no hydro stem. There's no hydro prefix, so we know it's not an ide, it's an ate. So the ate with the stem iode would be iodate. So iodate is IO3, -1 charge. So we're going to stick one H in front because of the -1 charge, and boom, we're done. That's iodic acid. Finally, one last example is we can do, how about hypochlorous acid? So hypochlorous. Now this is tricky. A lot of people see that hypo and they read it as hydro. They're different things. Hypo is not hydro, so this is not an ide ion. What we do is we look at the ending here, and we see, well, that ending is us, so it must be an ite. So we can essentially just replace that us ending. So their stem now is hypochlor. Chop off the or OUS. Hypochlor is our stem. Us is from an ite, so this must be hypochlorite. So we go look on our ion sheet for hypochlorite, and we see that it's ClO with a -1 charge. And so we're going to stick one H in front. And that's how you do that. Unfortunately, none of these examples had more than one H, so let's do one with more than one H. How about phosphoric acid? So phosphoric acid, there's no hydro, and it does end in ic, so it's an ate ion. So this would be phosphorate, which we don't find on our ion sheet. Oh wait, phosphorus is an example of one of the weird ones, so it must not be phosphorate, but just phosphate. Oh, that is on our ion sheet. It's PO4 -3, and a lot of this is just knowing your ions. You can see now why it's so helpful to know your ions. So we need to put H in front of it. How many H's this time? That is right. 3 of them. And then we always erase the charge when we're done. So that is how you name and write formulas for acids.